Hello everyone. I am presenting regarding the introduction of double haploid technology in maize breeding, and this is first of all I will quickly brief about the generally about the double haploid technology in maize breeding. I am Aamer Mumtaz from Pakistan, agriculture scientist, and I am a host up and I am Hungarian PhD scholar at Mate University. First of all, regarding hybrid maize breeding. The maize yield, the credit in the boost in maize yield in all world goes to hybrid maize breeding. It is in an estimate it is increases almost sixfold from 1930 to present. In Pakistan, its better example is that it is the average yield per hectare in 2001 and 2 was 16 more than 1600 kg per hectare. But now in 2019 and 20, it is 51,000, more than 51,000 kg per hectare. And the major role in the increasing boost for this boost in hybrid maize breeding is hybrid vigor. The and this, for this hybrid vigor, the homozygous inbred lines are very essential. Normally, the inbred lines produced through transfer breeding, they are almost 99% homozygous. We will look through about this traditional inbred line development, and you can see from this diagram that it will take almost 6 to 7 generations to reach up to 99% uniformity, and the inbred lines will be developed through successive selfing. And you can see that if it is reported as if 1% genome is heterogeneous, then there are fair chances that 300 genes will be segregating the next generation. And then the inbred line development through double haploid technology. In this, we only 2 to 3 generations we can develop an inbred line and with 100% homozygosity, because in haploid there will be n. When we double it to n, then it will be 100% homozygous. And in target, by associating that DS line in target infestation, it is a technology in which the section was made on gametes at gamete level, not on progeny level. You can see this diagram here is this gametes. This is the gamete selection. When we doubled the gametes through corticism application or any other method, then it will be 100% homozygous. But in progeny, the conventional breeding, you can see that there are 50% chances of heterogeneous population, for which we had to make selection again. Again, from this diagram, we can see that at the first step, DS line was developed. But in the conventional methods, after selection, there are 5 generations, and then we can say that the inbred lines is developed. Also, it is a cost and time. Both are saved in this. You can see that in SS4, we can make test cross and then top cross with multiples, and then we can select the lines. And it will cost, under estimate, it will cost almost $50 per row or $120 per line. When its minimum cost. And through DS line development, its minimum cost is about $15 to $30. And in just 2 to 3 generations, with maximum time saving, we can develop DS lines. There's a successful story of DS lines. Pioneer, the amortization company, which claimed that they produced 1 million DS lines in 2011 through this technology. But in last 80 years, they developed such 1 million inbred lines, but in a single year, they produce 1 million DS lines. This is the benefits of this technology. And we can use, we can achieve rapid genetic gains in breeding program by combining DH and molecular technology. And there are some advantages which I discussed before, that this is a reduce time and simplified logistics. And secondly, if we can achieve all breeding cycles in single generation. Also, they are less expensive on maintenance and selfing. Also, there is no need to do so subline production as we do it in inbred line selection. When we select beta selection in S1, S2, S3, then we sow the seed per line, seed per row generations, and then we made selections. But in this, there is no need to do no subline selection, because every single seed is a DS line. Also, we can focus more on general plant evaluation than to focus on genetic lines. This is a conclusion in briefly about DI technology. It increases efficacy, it increases genetic gains, and with molecular technology we can increase efficiency and we can efficiently use land decision of PVs. Now the real part. We after hardening this technology, we tried to introduce this technology at our institute at Maize and Millet Research Institute in Pakistan. This is a brief about our success story. In 2018, we imported the inducer lines from CIMET, and then in 2018 we made 1,500 almost crosses, and we obtained only 50 haploid seeds, and the induction rate was 3%, and only we obtained 5 DH plants. Then in 2018 winter, there are 2 seasons in Pakistan, winter and spring, in which BS can be sown. In winter, there were 15 DH lines. In spring, there are 14, and in last season, winter, we obtained 40 DS lines which is quite hopeful. And in 20, the data is under compilation. These more success, we are now achieving more than 40 DS lines. Then there are some hardness which we face in this technology, which I like to share. First of all, there is some confusion as the exact protocol. We first of all, we in CIMET manual and in training we heard that sow some seeds on germination papers and then dip it in water, and then after 48 to 72 hours they were germinated. We tried this method, but the germination was not so good. Then I contacted Dr. Ursula Frey from DS Laboratory, Iowa State University, USA. She recommended that dipping is not a favorable method. She recommended that first wash the germination papers with bleach solution, then dried it. After that, sowing should be done. And it will be also successful against fungus, which we are facing. And then we tried this method. We soaked it, then dry it in water. Then we placed it in incubator for 27 to 28 degrees centigrade for 70 to 96. Oh, sorry, days are wrongly written. It is actually hours, 72 to 96 hours. After that, we applied no water. And then after this method, the germination was 90%. Then there are also we tried method. We also tried some different methods like peat moss or soil in germination trays, but in this there was no success. Only the success was made with germination papers, in which the germination was 90%, more than 90%. Also, there was so much electricity problem as I was facing a network problem before my presentation. There, there was severe problem electricity in week of September, August, because there was so much temperature and short electricity. And we tried, but due to severe temperature fluctuations, there was severe mortality rate. But when we transferred second week in September, the electricity supply was normal. Then there was a fair chances and there was 60% survival rate, but in field it was only 30%. Then we have to move on third method, which is direct transplantation. I contacted with Dr. Vijay from CIMET Laboratory, Kenya. He recommended that they are also trying this method, and this method can be very helpful. So we tried direct transplantation method. And by this first in season, we saw only 25 seedlings and nothing was survived. But in next season, we decided to transplant the seedlings in a mild season and with full economic practice. Then we saw 50% of seedlings in direct into field and 50% through greenhouse. And after that, the quality treatment. After that, after practice of this method, we observed that there was very much success in direct seedlings. About 50%. It is not showing. I think it had to. I had to slide. Sorry. Arfan. And in this is and there are success of 70% in this method. But slide was so much large that it is not showing. I want to show you, so I am reducing its size. Now we can see it. Yeah. The percentage of soil plants was 70%, while in greenhouse, the plants which we transplant through greenhouse, they are 20%. And it's final harvesting 40 DS plants per plant, which were highest. But in season, in year 2020, we are obtaining more than 50, 60 plants per season, but still we are behind. There are some suggestions I am going to present regarding it. Germination papers are best for germination, which I optimize with this question regarding Pakistan, and there are some suggestions I am presenting it. Germination papers are best. Peat moss soil, I tried peat moss, I tried soil, but germination papers, the maximum are through germination paper. Also, 0.04% bleach solution was best for avoiding fungal attack. And also, dip it firstly in water, then for 72 hours, there will be no water application. After the spring season in Pakistan, this is best in January. Spring season, the main temperature rise in May, June. But if you so cortisone treatment, we did the cortisone treatment in January, then we transplant in at the last week of first week of January. Then there are fair chances that the plants will be survived, and there no need to AC control, or we can save almost 0.2 million Pakistani rupees. Mild temperature I think September, or if you want to plant in September, then September is the best for winter season. There are some future targets I set for my future. We set in this institute. We want to optimize regarding all techniques. There we have optimized many ways, but there are still lot work to going on regarding its germination, rotation treatment, greenhouse settlement, field transportation, etc. Also, we are trying to do some efficacy. We want to produce 200 DS lines per season. Then after this line, there will be so much genetic variability for us. And I am also working on a chapter regarding optimization of DR technology in Pakistan. And also I am working on development of local inducer lines through conventional breeding and molecular techniques. Thank you for your support, and thank you for listening. These are technical support from Simat and Dr. Usra Frey from DH Laboratory, Aamer State. Thank you. Thank you for your attention.